Welcome to Practical Techniques for Open World Materials. I'm Arda. Don't really try to pronounce the last name, that's fine. I'm a senior technical artist at TTK Games, and I'm going to talk about open world materials. So, two things. I'm going to talk about reducing landscape repetition and adding variation, just a simple method that we have used and that has resulted in nice visuals, and post-process materials for visibility. Starting with breaking the repetition. So there are a few methods that we use generally to break repetition. These could be micro variations, distance-based variation, hex styling, decals. I really do like hex styling. We're going to talk about RVTs first as a background knowledge. RVTs are runtime virtual textures. It's just a bucket of texture tiles that the landscape gets rendered to. And it only renders where you see in tiles, and only what MIPS you see. So it gets rendered to a few virtual textures, not just one. It can be used to reduce the cost of doing a lot of samples. Let's say you have a game with a lot of samples, as landscape materials do. You don't maybe want to run the same thing again and again and again in the same pixel. So do a lot of samples. And a few tips to begin with. It should not be used with animated material outputs because imagine it's like just a cache, just a snapshot of what you want to render out. And also avoid camera distance-based operations, but there's a workaround on that that I will talk about. So without an RVT method, let's say we have 48 texture samples. That's about like 12 landscape layers. That's not too much, and that gets constantly sampled to a landscape pixel, to every pixel that is seeing the landscape on your screen, every frame. But do we really need to do that? Not really. With RVTs, we can actually render these 48 texture samples onto an RVT on demand and in a partial way, where we just render the MIPS that we need and render the sections that we need to a virtual texture, and you just do a one virtual texture sample, and that's it. Mostly one. So I'm going to call this RVT patches. I don't think it has an official name. We're just rendering quads to an RVT for the landscape to blend together. It's quite cheap if your project is already using RVTs. It's great for adding variation that does actual nanite displacements, where if you use a decal to place a puddle, that decal and the displacement will not work too well. Then it almost will be borked, and you might see like phantom shadows and stuff. It's very ideal for making very local variations. You have a 2-kilometer map and you just want to put a trash pile somewhere on the edge of the map. In that case, you really don't need to spend one more landscape layer. Although Unreal optimizes those landscape layers per landscape tile, you really don't need to just add another special trash layer on your landscape material. And it's very artistically controllable, where you can place a quad, rotate around, scale it around. You don't have to have a uniform look to everything like you do with just a regular landscape layer. And it's handy by itself, but it's also handy when you want to add more density to the things. Like you have grass, you have the grass landscape material, sure, but you really do want to add some more bits and bobs around that grass. It's great for that too. You want to add some branches, sure, go ahead. Yeah, it's not a replacement for like using decals on your landscape, but it lets you do more with decals because it relieves the burden of doing stuff on the landscape from the decals. So why don't I just scatter meshes around? We have nanite. Well, there is a thing called nanite overdraw. It's quite expensive, and you don't want to just put things very close to each other on top of each other. That will cause nanite overdraw, even though the materials are opaque. And of course, it'll cause nanite overdraw if you're using nanite transparent materials, which is a horrible idea most of the time. So here's a test with a mesh approach and an RVT approach. Visually, they look very similar. I think my look can be done better, but basically they look the same, and the RVT patch has no overdraw almost, and the mesh does. And also, since you have control over the displacement density over distance, all of these just blend into nothing. And here's a better example. I've spawned, what, like 12 meshes on that landscape tile. It doesn't look too much. It's not like hot, bright white, but imagine adding more and more and more and more things on top of this. It's going to become an issue. RVT patches kind of lets you work around that issue. So why don't we really use decals? Let's just slap them around. They're just very straightforward and stuff. They're still good. They have use cases. They're really good for unique details. But overuse and huge size decals can lead to performance issues. It's not like you're going to have this problem in prototyping, but when you're going into production, if you've overused decals, you might have some bad time. And separating the decals from the moving elements can be time consuming. You have a mech that has, I don't know, you have a vehicle that has decals on it. It has to receive decals. You have a ground that has to receive decals because it has to do like explosion masks and stuff like that. It becomes harder to manage all of this, keep them in check. So this is a separation of function that we're aiming for also. And also they can be forgotten behind. They're not easy to catch if they're not intersecting anything. And also no displacement. If you want to do something fancy with displacements, like, you know, placing puddles, you're not really able to. It produces some glitchy look. So how do we set up the landscape for the RVT? We create 3 RVT texture assets, 1 for material, 1 for height, 1 for displacement, and then assign them to the landscape right over here. And then there's a handy little button that lets you create volumes automatically for your landscape. If you're doing more optimized work, let's say you're using the landscape for your level section and your backdrop, and you might want to just limit those volumes to your level section and do something else for the backdrop. And also these textures don't have to be the same size. Obviously the material needs more detail, but height, you're only going to use it for like blending stuff to the ground, so it can be very low res. And also displacement can be slightly lower than the material. And how do you set up in the landscape material? 2 things. The landscape layers render to the RVT, and the RVT renders to the material output. These 48, 64, whatever textures get sampled, put into an RVT. Just 1 or let's say 2 samples are done here for the actual landscape output. And I'm going to explain why I have that custom physical material output soon. Making RVT patches, it's very straightforward. You can literally make your material and use the same material, set it to transparent blending, and just chuck it in your RVT. But this is a basic material setup. You only need to do 2 things. Add RVTs so that they know they're writing to the RVT, and tell that it should never draw in main pass. It's also better if you just leave the material attribute output alone, because then you'll know if somebody has forgotten to hide this object in the main pass. So a few examples. You can trash the place. You can put a lot of branches. Also that branches texture really didn't have a good height. So the stretchy look is kind of caused by that. But you can do puddles, and they look pretty good, and they don't glitch out with the VSMs or anything. And there should be a fix for the materials for the puddles, because let's say you've put a puddle over there. What you would do with landscape layers is you're already painting a puddle material, or landscape material, so it probably has a puddle physical material assigned to it, so that gets baked into the physical material textures. But here you would need to manually pass your puddle opacity to the puddle physics material. That's it. And you can use the mask of the runtime texture input. Little more background knowledge to expand this idea. PCG, procedural content generation. It's a tool set for creating procedural content. You can use it for placing, you're just placing quads around. There's no reason for you to place like detailed meshes. You can use that for placing out quads rendered by the RVT. It's optional. It's a nice idea. You can combine it with other PCGs too. And the PCG setup basically looks like this, where on the left side you're sampling some points on the landscape. I'm just passing one material, but ideally when you're scattering things, maybe you're passing multiple materials, maybe you're passing one material and assigning some instance variable to it, so it just kind of makes things more random. But this is basically it. You just override material with the material attribute, and then, yeah, voila. Further exploration. These landscape patches can be set to skip rendering the higher MIPS. So when you're too far away, you really don't need it to be rendered anyway. So you can just skip them. That could be a small but meaningful optimization. And landscape splines can be written to the RVT, and Unreal Engine website has a I think it has a good example of that too, where they write the road to the RVT. So you want to do some distance-based effects for the RVT. If you put something where you reference the camera position, your material will be kind of borked, at least on 5.5. It's always going to be borked. So you need another reference point to render those textures. That reference point is this. You just get your output which you get which RVT MIP you're writing to, and you can divide it by the max level, which will get you something between 0 and 1. You can use it by itself. Lumen warning. Avoid using methods that rely on camera distance, especially on landscapes. This is not really related to the RVT patches, but if you still reference camera position, Lumen has no idea. But you can use this small little bit of code in a custom node to get the camera's previous position, which is just good enough for Lumen. On the left side, you have one where it references the camera. On the right side, it's referencing the previous position of the camera. It's a hard to catch issue, by the way. You will not notice it most of the times if your material is borked. But let's say you're blending mud and greens. That will end up in a dull green look on your lumen reflections if they're reflecting anything from the ground or any other material, really. Moving on to post-process materials for visibility. This talks about open world mostly. This is not specifically open world, but we make use of this quite a lot. And you can use this for visibility, outlines, VFX, and blurs. And there's a hint. Blurs. They're generally somewhat expensive. You need to do a bunch of samples for it. We really don't want to do it. We want something separable. We want to do something, save it out, take it back, do something else. And this talk is a secret multi-post process materials talk. Here, outlines. We had problems with outlines. We had problems getting them stable, smooth, or cheap. We just couldn't get it with a single post-process solution, or we couldn't use the old methods anyway. The challenges are it jitters because of the AA, because of the temporal nature of the TSR and the TAA. It has to jitter your buffers. Motion blur. You have a wall in front of you. You have a guy behind. You want to do outlines, but if your outlines are processed in a wrong spot, your outlines will be just motion blurred out of existence. And sampling many times, like I mentioned before, for blur type things, and I think outlines for me are blur type things because I want to smooth out my outlines. And if you don't do sampling many times, you will run into anti-aliasing. So the solution is user scene textures. User scene textures are user-defined transient render targets that can be written and read in post-process materials. I just copied and pasted this from the Unreal. That's fine. But how our particular setup looks like this, where we take the stencil value, that stencil buffer, from the scene color before depth of field, we do a bit of blur, and then we apply it back in the after tone mapping, so we get nice, good colors and all that. And all this bottom part is non-upscaled, all downscaled. You can blur things out quite efficiently because you're working with quite low resolutions. So here's how the process looks like. You read downscaled custom stencil. You assign some color to it. This is how we solve it. How you solve it might change, but the fundamentals are there. Read from the downscaled custom stencil. I also assign the colors over here. I treat it as just like a color map. And then we do a separable blur. Dealer's choice, you can do anything you want. I've picked horizontal and vertical box blur, that's fine. And I extract the outlines with after the separable blur, since we have created that like nice gradient around the edges. So the result is jitter-free, upscale artifact-free, smooth, not affected by motion blur. Also, I exaggerated the motion blur here just to show. Non-tone map color, what you see is what you get when you assign outline colors, which is what you want. And it has more opportunities for customization. I think our approach is pretty simple. And oh, jitter-free, asterisk, it's mostly jitter-free. I'll explain that. And you can hand over the controls for Z testing over to your design team, so they can change if something should be visible, the outline should be visible behind, front, or always, or some combination of fill or just the outline. So this is how we set up our user textures. We created 2 user textures, outline A, outline B. I'm not creating a third one, which you can if you're working with different resolutions. I suggest you work with that, but between horizontal, vertical blur and the output of the custom stencil, there's no change between the resolutions. So I'm just reusing the same user textures. Yeah, same process. Written to outline A, past the horizontal blur, written to outline B, past the vertical blur, written to outline A again, and then apply it back into the scene color. There's a small setup. All of them should be post-process materials. At the bottom, you can see where you're doing that operation, doing the material, and your downscale factors and stuff. But the most important part are these, where these are your input, output, parameter names. You don't pick your user-defined texture names here. This is just a setup for your material instance to pick up that thing. So you put these all in line. Order doesn't really matter. The only order that matters is the blendable order and the operation where they operate, or where the material runs, really. And here, these are our material instance settings. The first one will write to an outline A. The second one, since we named this input, will read from outline A to B, B to A on the left bottom side, and then finally we blend it back on the right bottom side. Small bits of nodes that you might need. Stencil, divide by 255 so you can use bit masking. We use bit masking. You don't have to use bit masking. You can just straight up use the values that the stencil buffer gives, but we're using bit masking to combine a few of the effects that we do. So, and then we do a Z-fail, Z-pass mask over there, which has some quirks that we will mention later. And you just, at the bottom most section, you can see we're selecting a bit mask, and then we're doing some Z-fail, Z-pass mask, just multiplying with the color. That's it. So the horizontal and vertical blur is just box blur. I mean, you can find this anywhere, really, if you search for it. And then we apply the outline. The thing that we did here was we want to get an unshaded color to pass as emissive and a mask in the opacity, where you've seen that they blur toward the black. We really don't want that. We want them to be just, if it's red, I don't want it to be red and red going into a transparent black. So I just remove the value from them. So just set the value to 1. You'll get a lower detailed, I guess, color info, but it's still fine. You're going to fade them away in a way. And then the bottom part, you're getting the value to mask all of it. And we're doing a little bit of a bridge function there to go from a linear response to a tent-like response. So we just get the edges and just ignore anything outside and inside. Oh yeah, problem. We are running into a problem. There's jitter. There's jitter everywhere. If there's downsides and upsides to both of them. If jitter is on, the scene depth and custom depth will match, but your whole effect might look like it's shaking a bit. You can still kind of mitigate that. If the jitter is off, scene depth and custom depth will have a mismatch. They will kind of glitch out if you try to do Z testing. Depth masking breaks and looks glitchy. So if you're doing outlines without Z testing, I suggest going jitter off. Otherwise, you should probably do jitter on. The mismatch issue can be mitigated with with putting an extra threshold between depth values that you're testing. What if I'm really smart? What if I try to unjitter the depth, which I have tried? I'm not smart. So you can get your temporal sample offsets and your render target sizes and try to un-TAA or TAA. It's not going to work. It is subsampled pixel, and you're working with whole pixels. No, just no. And this should be how the glitchy look looks. This is when two depths fight each other. Moving on, last talk, visibility boost. As you can see in the example here. Why do we do it in post-process? It avoids affecting lumen. That might be the biggest part, because I see a lot of people going like, oh, I just added to the emissive channel. But no, your character, while turning around the corner, will kind of light up the corner. That's not a good idea. No need for additional materials, no need to handle them, really. And I don't think you would like to do them with nanite. Also, it's just not limited to pixels that writes a mesh. So you can work with points of coordinates that is outside of a mesh, like you do when you're blurring. And all changes are post-lighting, so you're not affecting your lighting at all. The setup is not too different. I'm not going to go across the same things again and again. First step, we read the downscaled custom stencil plus do a z-test like we did there. I chose Kawase blur rather than a Gaussian blur. It is less expensive. It gave me better results in a cheaper budget. So also, you can run Kawase blur while downscaling and upscaling. So you're doing two passes while you're doing just one. So yeah, the last step is Kawase upscale plus a bit more blurring, and then exposure and contrast adjustment, and then you just pass that to your final image. Thank you for your time, and that is all. I am open for questions.
Not a question, more of a comment. Thank you for telling people about user-seen textures. Nobody knows about them, and they are incredibly powerful.
Yeah. Thank you. Oh.
So one, thank you for letting him thank you, because my question is, what are user-seen textures? And second is, how thick can your outline be? Because I tried to do that recently and I struggled. I couldn't get thicker than a certain feature.
I think you can even do flood fill if you feel really fancy about it. But you can run this. I'm running just one pair of vertical horizontal blur. You can run as many pairs as you want to make that thicker. There might be better methods to implement also. It's just these are just some texture buffers that you read and write to anything's game, and they're not really expensive because you're running them in low res compared to like actually doing blurring in a single pass. They're very, very cheap to do.
Just have a bigger blur factor. Just have a
You can run more iterations of this. So you will have something like vertical 1, horizontal 1, vertical 2, horizontal 2, vertical 3, horizontal 3. So you're going to go down 2 times downscaling every time you do this. And then when you combine them, you can get a thicker gradient around the edges, which will get you a thicker outline.
Using your outline method, could you, on next frames, can you play with the transform offset so that you can either have, stylistic effect or even trails of an outline?
No, they're transient. The textures they don't exist for the next frame. Right?
No, they don't.
Yeah. That's it. Okay.